Hi, Jenny. This is looking great. This spreadsheet, very impressive. I'm just going to make a few little things here to show you, for example, how we might do on a spreadsheet. The first thing I notice is that third row is getting frozen too, whereas we'd really just like those top two rows to be frozen. So if we go to View Freeze two rows, that way that third row, I don't think there's anything special about it, so we can slide it with the rest of the data. The other thing I was trying to think of a quantitative variable to put in yours, and one seems like patient age. It's certainly quantitative. It seems like it could be a useful one. I actually had to play just to make sure, but it turns out it's very simple to do. To calculate, we just take the date of the event minus the birth date of the person who the event happened to, and it calculates this. And originally I thought, what's that number? Then I realized it's how many days there are in between those two dates. In other words, if we want their age, all we have to do, I'm putting parentheses around this subtraction, and then I'm going to divide by 365. Let's make it a little more accurate here, 0.25, throw in the leap years there. And this would give the patient's age. So this particular person who was born in 1964, if you would add 48 to that point, the decimal here, you'd get that it was 2013. And I double-checked a couple of those. I'm going to click on that, and then we could drag this down, but also if we just double-click, it'll fill in there. So immediately I'd want to pop in and check what's this age 0 doing. And my guess is that the patient age, I don't know if that was either a typo or if it was a baby slipped the day they were born, slipped out of the thing. I don't know. So one advantage is this could help you catch errors if that was an error, or if it's not. I guess it's possible something happened the day the baby was born. These numbers are a little nasty looking for age, so I'm going to go up to Format Number. Let's just make it a nice integer there. That'll be a lot easier to read and deal with. Okay, so now that we've got that, why don't we go through quickly the steps on calculating average and standard deviation, just in case we would want to know that. And I'm not sure where we would want to put it, but let me show you this. If you select C and down here, click on this, we can see that the average age, 67 years old. Let me do the standard deviation as a calculation, though. If I do an equal sign, STDEVP, that's standard deviation of the entire population of patients, and then I'm just going to select all of these. Oh wait, how many do you have? Never mind, you have a lot. So what I'm going to do is I'm going to grab this scroll bar over here, go all the way to the end, and then hold down Shift and click on that last cell. That'll select all the ones. What a beautiful database here, 530 patients there. And here we get the standard deviation. So we already saw that the average was 67, but now we know that the standard deviation is 17, and that number is a little harder to interpret. Basically, we could take 17 below this and above this and say the majority of our patients are between ages 50, which would be taking 17 away from the average, and 84, which would be adding 17 to the average. So the majority of these events that are happening are between the ages of 50 and 84.